Okay, chapter 10, section 7 is on special segments in circles. What we did before was different angles created by the secants and the tangents and all that good things. Now we're looking at special segments that are created by secants and tangents. Okay, so the first theorem is called the secant segment theorem. The chord segment theorem. If two chords intersect in the interior of a circle, so here's our two chords, ED and AC, they are intersecting inside the circle. Remember, interior means inside. Then the product, what does that word mean? What are we doing to the two parts if we're finding the product? We're multiplying. The product of the lengths of the segments of one chord, I kind of color-coded them here so you can see, so this like yellowish gold segment times the red segment is going to equal the product of the lengths of the segments of the other chord, so blue times purple. Okay, a lot of words. Again, don't worry about the words, just try to draw a picture and you'll see it a lot more clearly. So again, we have each part of the segment multiplied together is going to equal the two parts of the other segments multiplied together. So that intersection is cutting each chord into two parts, and we're going to multiply those two parts and set them equal to each other. So if we throw some numbers in here, this will make it easier for us to see what's going on. AB here is 2 centimeters, BC is 10. We're going to multiply those two, and that should equal BD here, which is 4, times BE. Well, let's see if they do. Is 2 times 10 the same number as 4 times 5? Yeah. Okay, so the products of the two parts should equal each other. So if you're given any three of these numbers, you can solve for the fourth one. Example. Here we have two chords intersecting inside, which means the product of the parts, 8 times x, should equal 12 times 9, the product of the other two parts. So we're going to set our equation up like this. 8 times x, we usually say 8x. 12 times 9 is 108. So then when I divide by 8, again, if you have your calculator with you, which you should, to check my numbers to make sure you know how to punch this stuff in, you should get x equals 13.5. Remember, you're going to learn way better by doing. This is just an introduction. I'm not expecting you to know how to do it 100%, but you need to have the gist of it and be coming in with just questions, not expecting an entire lesson. Here's another one, just like this. So how are we going to set this up? What are my two parts on this chord here that we would multiply together? 15 times 5. That is going to equal the two parts of this other chord. What are the two parts of this other chord? 6 and x. 15 times 5 is 75. If I divide that by 6, use your calculator. Tell me what you get. Hopefully you got B, 12.5. Okay, simple enough. Again, you just have to remember the relationship. That's the hardest part about this chapter, is remembering all the different relationships. It's all just adding, subtracting, multiplying, and dividing. You just got to remember the relationships. Okay, so here again, we have two parts, color-coded the exact same. It's the same picture, I just threw different numbers in here. So what are my two parts going to be for this chord ED? 6 and x plus 2. You need to remember to put these phrases here in parentheses. And then what are the two parts of AC? 3 and 3x minus 1. So when we write that out, including the parentheses, it would look like this. Now, what do we need to do to get rid of these parentheses? We have to distribute. You can't forget that. Okay, that is just basic algebra you should have learned last year. So when we distribute, 6 times x is, 6 times 2 is, 3 times 3 is, and 3 times negative 1 is. You should have had this written down. Okay. My goal in your notes is for you to be working these problems along with me and trying to do as much independently as you can. For example, you should be able to solve this now. You should not be waiting for me to solve it for you. Okay, and I'm not going to show every step because you should know this by now. So if I move all the x's to one side and move all my numbers to the other, I get 15 equals 3x. And then the last step, to divide by 3, x is 5. And again, remember to always go up and check your directions. It said to solve for x, so you're good. But what if it had said find the measure of BC? You'd have to go over here and find BC. Well, BC was 3x minus 1. And we now know that x is 5, so 3 times 5 is 15 minus 1 is 14. Okay, so make sure you're reading the directions. Okay, here's another theorem that's wordy. Again, I'll read it to you, but it's much better to just draw the picture. If two secant segments, okay, so you should stop right there and think, what is a secant segment? Oh, a secant goes through the circle and crosses it at 2 points. Okay, so we have 2 of them going through the circle. If they share the endpoint outside the circle, so they're going to intersect outside, it's going to make like a big V with part of the V going through the circles, then the product of the length of one secant segment and the length of its external, what does external mean? The outside part. And again, it's the product. So what are we doing? Adding, subtracting, multiplying, dividing? What are we doing? We're multiplying. Okay, so you got to learn how to dissect what you're reading. Is going to equal the product of the length of the other segment and its outside part. So again, just draw the picture. So what this is saying is we're going to take the whole thing and we're going to multiply it by the outside part. And that is going to equal this whole thing multiplied by its outside part. So AB times AC equals AD times AE. Okay. Whole times outside equals whole times outside. Let's throw some numbers in. Okay, so I'm given the 2 parts, but I need the whole. Can I find the whole thing? Can I find AC? This goes back to chapter 1. The whole equals the sum of the parts. So if I want to find AC, I'm just going to add 9 plus 11 and get 20. Well, what do I get here if I add 10 plus x? That's what I get, is 10 plus x. So here's the whole, here's the outside. Here's the whole, here's the outside. I'm going to multiply the whole times the outside, the whole times the outside, and set them equal to each other. 9 times 20, if you have your calculator, is 180. I must distribute here. 100 plus 10x. So 180 equals 100 plus 10x. Now it's just a two-step algebra equation. I subtract the 100, I divide by the 10, x equals 8. Did I answer the question? Yes. So what is the whole length of AE if x equals 8? AE would equal 10 plus 8, which is 18. Okay, so again, remember I can ask this in a bunch of different ways, but I can't possibly work it all the different ways unless you want to listen to me for an hour, which I think 30 minutes is probably too much as it is. Okay, let's do another one. Okay, this one already has everything labeled, but remember, if it doesn't, you just read the description and mark up your picture. So it's the whole times the outside equals the whole times the outside. What's the whole thing here going to be? Okay, we got to add the two parts together, right? And we're adding here, we're adding here. I can't do anything here. I cannot add an x with an 8, so all I can do is distribute. 8 times 8 is 64. 8 times x is 8x. But here, I can add these. I get 34. 34 times 10, you just add that 0, is 340. Now I move my 64 over and I get 276 divided by 8 is 34.5. Did I answer the question? It says to find x, so yes, I did. Okay. Try to do this one on your own. Pause the video. Try to do it on your own. You've got answer choices here, so at least that gives you a shot to check yourself. So pause and come back and watch my solution. Okay, so here we go. We need the whole thing. Well, the whole thing is going to be 27 plus 25, which is 52. The whole thing here is going to be 24 plus x. Okay, so now if I set this all up, I should have the whole thing times the outside portion equals the whole thing times the outside portion. Okay, so what is 52 times 25? 1300. If I distribute here, I get 24x plus x squared. Okay, this goes way back to Algebra 1. We really have not talked about this year. I'm going to rewrite this. I'm just flipping the equation around. When you have an x squared, you have to get everything on the same side of your equal sign. I'm not going to throw any like this at you, but this is a challenge one. Okay. And this is where you have to factor. I don't know if you remember doing this in algebra or not. You will have to do it in Algebra 2 next year, for sure. For sure. Okay, so we got to figure out something that will multiply together to be 1300, but adds together to be 24. So that's kind of hard. Let's see. To be honest, I don't know what it is. Let's see. 50 and 26 This needs to be positive, and this needs to be negative. So 50 times 26 makes 1,300. 50 minus 26 equals 24. I don't know if you remember doing this or not. You can fast forward through this. I'm not going to throw anything like this at you, but if you want a challenge, you want to know how to do it, you can keep looking. We set each one of these parentheses equal to 0. So in this case, we get x equals negative 50. In this case, we get x equals 26. Lengths and distances can never be negative. So we have to go with the positive answer, which is C. Okay, so just throw a little challenge in there. You will see something like this type of equation in Algebra 2. It won't be with this kind of figure, but you need to know, you got to remember how to factor. Okay, last theorem for today, I think. Secant tangent segment theorem. If a secant segment and a tangent segment share an endpoint outside the circle, okay, so we're making a V, but this time part of it's going through, the other part's a tangent, so it's touching the circle. Then the product of the length of the secant, product, again, we're multiplying the length of the secant times its outside part, is going to equal the square of the segment, the tangent segment. So we're squaring this. So again, let's just look at the picture. Copy down this picture in your notes. And this is, again, saying the whole times the outside. The whole times the outside. It's actually kind of what we just learned. It's going to be equal to the whole times the outside here, but because the whole and the outside are the same, you're just squaring it. So if you want to just remember one pattern, remember it's whole times outside equals whole times outside, and it will work here as well. It just so happens that with the tangent segment, the whole and the outside are the same, so it's the same as just squaring that segment. Let's throw some numbers in here so you can see it better. What's the whole thing here going to be called? If we add the two parts together, it's going to be called 6 plus x. Okay, so we have the whole thing, 6 plus x, times the outside portion is 6, is going to be equal to this whole thing times the outside portion, which is the same thing, again, 12 squared, or 12 times 12. We must distribute here. You got to know how to distribute to do this whole section. Whoops, that's a 6x equals 144. Subtract the 6. I should just let my computer do it, huh? It's a lot neater. Divide by 6 and you get 18. I forget I took all the time to do it nice and neatly, and I end up scribbling all over the place. Okay, what's this one going to look like? What's the whole thing over here? What's 20 plus 25? 45. Times which part? The outside part. Again, when you get to these multiple choice ones, you should pause the video, try to work it out in your notebook and see if you can get the right answer. And then start the video again and check yourself. It's going to equal the whole times itself, so we get x squared. So this is 900 equals x squared. I don't want x squared, I want x, so remember to undo squaring, you got to square root it. The square root of 900, if you use your calculator, you should see that it is 30. You should know that anyway, because the square root of 9 is 3. All right? Well, there we go. So we had a shorter video today. So come in with questions. Make sure you get it clarified in class.